November 121 Mike, your turn. Taxiing 111.
Hi, I'm Mike Thompson, and welcome to 121 Point Mike Ground School. Today, we're going to talk about stalling. I'd rather not talk about it right now, though, so I'm going to wait a while and come back to it later. Enough stalling. I'm back. Here's what you need to know for your test. A stall occurs when an airfoil exceeds its critical angle of attack. And a stall can occur at any attitude and airspeed. That's it. You can go now. Want to stay? All right then. I'm going to explain all about stalls and how to recover from them. You're going to need to know this stuff on a test and in the air. Now, what did I mean when I said critical angle of attack? Let me back up a bit and explain all that you need to know. An airfoil is the cross-sectional shape of the wing or tail surfaces. You've seen this shape before. Why do we use airfoils anyway instead of just flat plates? Airfoils behave better. That's why. If you run a flat plate through the air goes around it, no surprise there. But when you start to tilt the plate, let me get rid of this thing. When you start to tilt the plate, you're now directing some of that air downward. And the fact that you turn the air means that there's a reaction force in the other direction. And now you're creating some lift due to the bottom surface. Now, you've also created some negative pressure on the top surface because the top surface is facing away from the flow. This also creates some lift from our flat plate. As you start to tilt your flat plate up some more to get more lift, then the air can't stay attached to the upper surface because this turn from here is too sharp. Fluids don't like sharp curves. Cars don't either. I'm sure you understand. It all boils down to inertia, really. Things want to keep doing what they're doing and don't like to change direction or get off the couch when they're watching TV. If you want a fluid to change direction, you have to ask it nicely by using a gentle bend, especially when it's moving really fast. When you're driving down a road and you come upon an intersection, you have to slow down to make that 90-degree left turn, don't you? On an interstate, you can maintain 80 miles per hour around the corner because they have a large radius, don't they? What would happen if you tried to make a 90-degree turn on a city street at 80 miles an hour? Yeah, you'd separate from the road, wouldn't you? And you'd be over and crash into that corner Starbucks' front window. Air and water behave the same as your car. This is why airfoils are shaped the way they are. We like to keep the air attached to the wing and, of course, not fly off of it. A flat plate can't be tilted very far from the airstream because the front edge is simply too sharp. It basically cuts the airflow like a knife. The angle between the airfoil's axis, or chord line, and the airflow is called the angle of attack. Angle of attack, AOA. We make airfoils because they behave better. There are a few other reasons, like they're great at producing lift, they're aerodynamic, they're good structural shapes, they allow internal storage, etc. But we'd like our air to stay attached, wouldn't we? When the air detaches from the upper surface of the wing and we experience a loss of lift, the wing is stalled. Every airfoil has a particular angle of attack by which it can be tilted before the airflow separates. Typically for general aviation airfoils, this critical angle of attack is between 15 and 20 degrees. The angle at which a stall occurs is the critical angle of attack. Test question. The angle of attack is the angle between the airflow and the airfoil's chord line. The critical angle of attack is the angle at which the airflow separates and the wing stops producing lift. The wing is stalled. A stall does not mean that the plane falls out of the sky instantly, but you'd better fix this situation rapidly before you experience the ground. Stalls are sometimes thought of only occurring at slow speeds, but this of course is not true. A second test point I mentioned is that a stall can happen at any attitude and any airspeed. A stall happens anytime a wing exceeds its critical angle of attack. Maybe you can envision a couple of situations where this might happen. And the first one that we're going to discuss of these other scenarios is associated with a power-on stall at takeoff. A power-on stall is what it sounds like. You have power on, and yet you're stalling. How's this possible? Long pause. you should know that the answer is that you've exceeded the critical angle of attack. That's when a wing stalls. During takeoff, you have full throttle, a high pitch angle, which probably means you also have a high angle of attack since the wind was probably blowing this way, right? This angle between the relative wind and your chord line is large enough to cause flow separation and the wing stalled. Similarly, during a hard corner at a high bank angle, you can get your wing to stall. Accelerated stalls is a textbook term for what I'm talking about here. You have to pull back during a turn to maintain altitude due to a loss of vertical lift. This pullback increases your angle of attack, which is what? The angle between the relative wind and the wing's chord line, the front to back line. The last type of stall is the power off stall. This is the one that might occur on approach when you have a low power setting and then you let your airspeed get too low. I think this one's probably one that kills the most people. So, in an effort to keep you alive and help you on your test, I'm going to tell you how to recover from a stall. You won't be a pilot if you don't know how to do this. Now, you should follow whatever procedure your flight manual says, but generally you'll recover from a stall in this order, and this will show up on a test. Reduce your angle of attack. This means push forward on the controls. You're going to roll level, and then you're going to add power. We do it this way because this sequence is the most effective. The part that gets people killed on approach is that their instincts are to pull back on the stick and try to avoid the ground. Now I know it doesn't make intuitive sense to push yourself closer to the ground now, does it? But that's what you have to do. You've got to get the wing flying again. And the only way to do that is to reduce your angle of attack below the critical angle. And the only way to do that is to push forward, even if that means skimming the treetops. Pulling back will certainly not work. Ever. Reduce AOA by pushing forward, roll wings level to get your lift vector pointed up, and add power to increase your airspeed and your lift. All of this takes less than 2 seconds and it'll save your life, and you'll get extra points on your test. Your airplane will have a stall warning horn, which will sound as you're about to stall. It's most likely a little switch which is set at an angle of attack slightly less than the critical one. The airstream keeps the switch down most of the time, but as you approach the critical AOA, there's less downforce on the switch, and once you start getting more air below the switch than above it, it flips up and activates the warning horn. You might also feel a buffet in the controls as the turbulent wake hits the tail. Now would be a great time to initiate your stall recovery procedures. Now, I want to note here that the published stalling speed in your flight manual is typically only valid for 1G unaccelerated coordinated flight at maximum gross weight with a maximum forward CG. It is certainly possible to fly slower than the published stall speed. It's also possible to stall at any speed. Maintain coordinated flight, especially in a stall, so you don't accidentally enter a spin. I'll cover that in a spin video. Reduce your AOA, roll level, add power. Do we need an acronym for that? Yeah, we probably do. Push level, add power. PLA? Push level, add power? PLA, yeah. Any 3D printer people out there? No? How about... I don't know. I got nothing else, but I'll certainly take suggestions for an acronym down in the comments. The wing stalls beyond the critical angle of attack. Any attitude and any airspeed and PLA. That just about does it for this one, I guess. Now you know what you need to know for your test regarding stalls. This information just might save your life. You too. Go ahead and subscribe if you haven't already. It's free. You'll be notified when the next video is out. Subscribing will certainly help me out, as will leaving a comment down there. And stay with me on 121 Point Mike.